COVID-19 is caused by the SARS-CoV-2 virus, where most people experience a mute to moderate respiratory virus. To access and diagnose and triage vaccine, this work developed a COVID-19 classification system to assist visual imaging. For this purpose, the neural network model with net 52, with net 101, 52, DensNet 121, DensNet 169, DensNet 201, instead with net PG60 and PG19 were used to compare their precision, accuracy, recall, and specificity. For this, the image was segmentation by a neural network and tests of the long image were generated with certain input for the different classification mode. In the probabilistic practical was generated to assist in the interpretation of the results of neural network. The segmentation between a Jaccard similarity of 1940 to 1940.30 while for the classification, the panel's precision, specificity, accuracy, and revocation are evaluated compared with the reference method, where the DensNet 121 obtained an accuracy of 99.28%, while with net 52 presents a specificity of 99.72% before COVID-19. In terms related to artificial intelligence have gained evidence in the media due to their presence in the device, such as smartphones, POSs, and autonomous cars, where, as a general concept, users seek to automate decisions executed by humans. As with everyday tools, medicine and more specific, the area of radio has undergone major technological changes in recent years. The symptoms that can be visualized in radio are present in three stages: initial, progressive, and strong. In the early stage of the disease, the lungs show multiple small irregular channels and interstitial changes, most apparent in peripheral zones of the lung. In the progressive stage, there are multiple complex biological and infiltration in both lungs, and in the strong stage, there is a consolidation of things. These arguments tend to involve the performance of all parts due to 2012 in segmentation by changing the error into log cost loss and using other models of neural networks. To make it possible, I used a net to separate lung of bacteriology and radiology, evaluating the model using FU score and Jaccard score parameters. On the other hand, for classification, I used the models with net 50v2, with net 101 v2, and net 121, and net 169, and net 209, VGD60, and VGD90, and interception v2 using as parameter precision accuracy recall. This project is made using Python, Keras, and public datasets. The segmentation with two full datasets. They are provided by the Department of Health and Human Services of Montgomery County, Maryland, the United States, and Shenzhen People Hospital Group of the Guangdong Medical University in Shenzhen. Contain a total of 8,806 radiographers for the next use. The dataset provides which was generated based on both datasets form a set of X-ray images and their image masks, which are also divided into training, validation tests. The proportion of users was 72 18%, and 10% respectively, whose objective was to reduce the bias. To reduce the impact of the reduced number of images, the datasets are increased artificially to 10,000 images using data segmentation. Applying correction grammar also knows less transformation video stores and flip covering. The images are of different size and types, making necessary normalize the improve the network performance. In this way, transform the image from 0.8 to float to float with 13.2 resize each to 215 and for 256 pixels. Are numbered from 0 to 1. In addition, a gamma correction of 0.5 was applied. The weights were inserted in the logic distribution in training using the log cost dice loss function, which had a max possibilities and learning range of 0.001, reducing a quarter of the validation error with the patency of blocks. For the classification of the X-ray image that was used available for charge containing 103 images of each, with 853 are X-ray images of patients with COVID-19, 1,887 of patients noticed, and 4,360 of patients with pneumonia. The classification dataset used was public. We have more than 70. The pre-process of the images consists in normalizing the probability of P. The pre-process of the image consists in normalizing the image furnished by segmentation into 0 to 1, resizing the image to 124 to 124 pixels. Apply the gamma correction of 0.55 and perform the image segmentation with the mask generated by the segmentation model. Next, the image is put in several random packets of size 224 to 224 pixels, avoiding new errors of as shown in figure 1. This process aims to reduce the inputs for the local classification model from which the prediction for each package are made. In the figure 2, you can see the Jaccard score. And the Jaccard score, the unit segmentation model has evaluated into the test dataset with 18 images through the parameters of the Epsilon score and Jaccard score to compare the segmented results with the reference method. Using Epsilon score, the 5 most similar results in the inter dataset are respectively 79.23, 18.56, 18.99%, 81.25%, and 82.48%. The 5 best results are 97.01%, 97.06%, 97.11%, 97.16%. The average results of the Jaccard score are 93.09% with a standard deviation of 4.07%. And for FEM score, we have the 5 worst similar results in the inter dataset are respectively 79.22, 18.56, and 18.99%, and a weighting 81.55. 82.25% and 82.48%. The five best are 97.71%, 97.06%, 97.11%, 97.16%. The average which is 93.79%, with standard deviation for 0.7%. In the figure cut, you can see an image of the example, and of the example of the image predicted by the model. The figure shows a pre-processed image of X-ray images containing the test data set. Figure 4C shows the reference mask provided by the data set, and figure 4C shows the mask generated by the segmentation model. The classification in global approximation price evaluates for precision, accuracy, specificity, and recall. Table 3 shows the results in which the best performance for each of care is highlighted. And as the object of the work is to develop a medical diagnosis, the most important part of the network are precision and specificity. The neural network with better precision must match 121, and the network with better specificity was the next 15 B2. Analyze the other patterns, we observe that each general mismatch 54 B2 present the best performance. Next, the performance of the network as compared to the other. Table 4 compares the precision results and table 5 compares the specific results. It is noted that all models present are more accurate results for the classification of COVID-19 and pneumonia. However, for case of no source, the literature has better results. The literature obtained is very specific for the COVID-19. However, the results for the neural network reproduction are used for in the classification of blood cells and pneumonia. The figure 6 shows the Grad-CAM. Finally, so the published Grad-CAM method, the head map of the models injected are generated using 400 milliseconds to obtain a clear image as shown in figure 7. In head are the localities the most influent, the description the most influence, and in blue the least influential volume, where you can see that regions of interest are in the left one. Testnet 121 shows best disperses results. Now, and if the current funding situation in these words, new diagnostic methods for these new research are increasingly necessary. These are to improve the purpose of the activity reference. The DESNet 121 network contains improvement in the precision of 9.95% when compared to the literature. Whatever, in the specification, the performance was 0.7 worse. When DESNet 52 obtained 8.78 by precision than the literature and 0.28 worse performance in space, despite the worsening of specificity in DESNet 15. This value was more compared to the high gain that is network achieved in precision. Even when analyzing the image generated by the practical probability, it can be seen that the regions of interest are in similar locations, whereas the DESNet models obtain less diffuse regions. I'd like to thank the team of professors and college from the automation and instrument laboratory. electrical engineering department of the State University of Londrina, well, and other sectors involved. Thank you for your attention.